34 fast food restaurant hourly employees were surveyed to see how many hours they worked per week on average. The following data was obtained, and we have the data here. Assuming the population standard deviation is sigma equals 9, construct a 98% confidence interval for the mean number of hours per week that the population of fast food restaurant employees work. So for this problem, we want to construct a confidence interval. We want to construct a confidence interval for the population average hours per week that fast food restaurant workers work. We have a confidence level. It's a 98% confidence level, so that will tell us, that will help us calculate that margin of error for our confidence interval. So let's break it down piece by piece, and the problem helps us do that. So we first need our point estimate, our x bar. So I'm going to move this data into my calculator, copied it over, storing it in variable x, okay? And then I calculate the mean of this data like I usually do. I first calculate the length. That should be 34 because that's how many people it says we've surveyed here, and indeed it is 34. Okay. Then to calculate the mean, I add up all my data and I divide by how many data points we have. So the mean, the point estimate of the population mean is 36.44118. That's my sample mean. Okay. Now to calculate my alpha, remember that's the probability that my population proportion will not be in my confidence interval. So it should be confidence level plus alpha equals 1. That's generally what it is. It's the probability that the population mean will be in my confidence interval. This is the probability that my population mean will not be in my confidence interval. Those are the only two possibilities, so add them together. That's 100% of the possibilities, which means alpha is equal to 1 minus that confidence level. Okay, so in this case, that alpha, that's 1 minus my confidence level, which is 98%. It's a 98% confidence level. So express that as a decimal, that's 0.98. So that is my alpha. Alpha equals 1 minus my confidence level of 0.98. So my alpha is 0.02. Okay? Now to calculate my margin of error, remember for estimating the population mean, the margin of error is going to be my z alpha over 2, the z value with area of alpha over 2 to the right, times the population standard deviation over square root of n. Okay, so we first need to find that z alpha over 2 before we move on. Okay, so if we think about this in terms of the standard normal distribution, so we have mean 0 since we're dealing with the standard normal distribution. We want the z-score, this z alpha over 2 here, so that the area to the right is alpha over 2. Okay? In our particular case, alpha over 2 is 0.01. So instead of calling the z alpha over 2 and alpha over 2, if we plug in the particular value for alpha over 2, we would get z of 0.01, and the area to its right is 0.01. Okay. So since we are told the area to the right of the z-score and we want to find the z-score itself, that means we want to use the q-norm function and plug in the probability, right? We're told the area, which is equal to the probability. Now the q-norm function expects an area in the lower tail. We have an area in the upper tail, so the way we deal with that is we just subtract the area we know from 1. So 1 minus 0.01. That is going to give us our z alpha over 2, or in this case, our z sub 0.01. That's 2.326348. Okay? By the way, if you want to be a little bit lazier, you could just write alpha over 2 here. That will also work. Gives you the same thing. So you could either put in exactly what alpha over 2 is, or just type alpha over 2 and let the computer do the hard work. Okay? So we have our z alpha over 2, which means we are ready to calculate our margin of error here. So I'll just call this z. If you really want to call it, z sub 0.01 or something, you can. But it's the only z we're dealing with. So I'll just call it z for simplicity. Okay? So that's our z, which means our margin of error is our z value that we just calculated times our standard deviation. The problem tells us that our standard deviation is 9, divided by square root of the sample size. So square root of n, or square root of 34 if you want to put it in exactly. So all I'm doing here is I'm using this formula. Plugging in the z value, okay, I'm using the variable. Plugging in my standard deviation, we're told that in the problem. And dividing by square root of the sample size. So that's square root of n, where n in this case is 34. Okay, so that's going to give me my margin of error. So my margin of error is 3.590688. So with that, we are ready to calculate our confidence interval. Our confidence interval, remember, is our point estimate plus and minus our margin of error. Okay, and you do want to get the order here right. Smaller one, bigger one. Okay? So I have all that already in my calculator. X bar is a variable in my calculator. E is a variable in my calculator, so I don't even have to think about what the numbers are. All I have to do is type in x bar minus my margin of error for my lower bound. So that's the smaller number first. And then my upper bound is x bar plus my margin of error. And that is my upper bound. So we are 98% confident that fast food restaurant hourly employees, on average, work between 32.85049 and 40.03186 hours per week.